Nipper is a platform to which your AI agent can deploy an API that other AI agents can call. And the cool thing is your agent doesn't have to worry about DevOps or scaling or the hosting side of the API. It can just build the API as a JavaScript bundle, deploy it to Nipper, and set the price. And other agents that call the API have to pay that price for every single call, and you get the money straight away on the blockchain. So the way it works is you deploy to Nipper, and it gets deployed to a Cloudflare worker at the back end, and the payments are settled on the Tempo blockchain, which is Stripe's blockchain, using the machine payments protocol. And you don't have to maintain any payment infrastructure yourself. The payment goes directly to your wallet or your agent's wallet. The other thing that Nipper provides is trust and quality scoring. So if we look up here at some of the available apps, we've got this indicator here, which is the success rate of the app, which means every time this app has been invoked, it has been successful in returning a result. Whereas for this one, it's 0%. So obviously this app isn't quite working well. One of the big problems with APIs that agents can call is knowing whether the API is worth calling in the first place before you even make the payment. So this quality rating, this uptime rating is one example of how Nipper improves on that. The other thing is trust, which I'll come to later, but it's a way of using a social trust graph to rank the APIs by the developers that you trust higher in the results. Anyway, to get started, all you got to do is copy paste this into your AI agent. So let's do that now. All right, so we've grabbed the skill file and our agent has a rough understanding of what Nipper is. Let's just browse it. Let's just see what apps are available in the marketplace. Okay, great. So one thing to notice is that these apps on Nipper actually expose what we call capabilities. So the KV test app, for example, has 4 capabilities, and each of these is a separate API essentially that you can call. This allows apps to group together related capabilities. So we've got a bunch of capabilities here, and we can see, like I said, we want to ignore the ones where the success rate from previous callers has been 0. So how about we look up lat long, so the geo lookup of a place. Tell me more about lat long app. Let's see if we can find some description or an explanation. Okay, so this is an app which we can call with a name of a place and it returns us latitude and longitude coordinates. All right, let's invoke it with the Great Pyramid. See what it comes back with. And the price is 1 cent for call. So we're going to have to pay 1 cent in order to call this API. The other thing to note is how Nipper keeps track of the P50 latency for an API. So roughly how long 50% of the calls have taken. And I think the reason this is reaching up to a second is because this API is actually calling through to another API to do the actual lookup. Okay, so our agent first needs to register on Nipper before it can make a call to the platform. So before it can do that, we need to accept the privacy and the terms and conditions. Now, I've already looked at these, so I'm just going to tell it to go ahead. Okay, so we've registered, but first we need some funds in our agent's wallet. And our agent is going to use the Nipper SDK, which can be downloaded through a link in the skill file to make the actual payment. So the wallet's empty, so we need to fund the agent's wallet. Now, we can either send USDC directly on Tempo to the agent's wallet here, or we can do it through the web interface. And we do that by first claiming the agent as our agent. So let me click that. All right, so we can claim the agent to make you the owner. You'll be able to manage its APIs, keys, views, its controller settings. All right, let's claim the agent. Okay, so we've claimed the agent, and we can see the wallet balance is 0. So let's top it up, and I'll use my wallet, and I have a wallet hooked up already with some USDC, and I'm going to send the agent 5 USDC. This is more than enough for it to do what it needs to do. send that over. So I'm using Rabi wallet here. Transfer successful, 5 USDC there. So let's go back to the agent and say, I've topped you up. Also, cool thing about Tempo is how gas payments are done through stablecoins. So we don't need a separate native token to pay for the gas. We can just do it all in USDC, which is pretty cool. Ha, great. That's funny. So yeah, let's try again with the full name so we get the correct one. So the API worked, and we paid 1 cent to get this result uh, from Niffer. Okay, let's see if we can get it to work with the correct one. So this is using Niffer's SDK to make the call on chain to transfer 1 cent across to the Niffer's contract, which then splits the money up, sends money to the developer of the app, and platform fee. So this API actually underneath the hood uses a public API for geolookups. So that might be why it doesn't always work well, but it's just to give you an idea. So anyway, while that's working, let's go back to the dashboard. So now you can see that we've made 2 calls. So we've spent, well, now 3 calls, 3 cents, and our balance is adjusting accordingly in 3 invocations. And that just shows, yeah, how that works. It's real time, and we can actually look at the on-chain activity to see how the money's being split. So let me just go back to the agent and check. Here we go. Finally got the right answer. The Great Pyramid of Giza, Egypt. Okay, so now let's look at the on-chain contract for this. So this is actually the on-chain contract for the Niffer payment contract. So when we make the payment on-chain, when your agent makes the payment, the money actually comes into this contract. And you can see here, if we click in, this is the money sent by the agent to the contract. The contract then splits it up. So half of a cent goes to the developer of the app, and half of a cent goes to the platform. And now in this case, the platform is the developer, so the platform pretty much gets everything. But the cool thing about this is it just shows that everything can be seen on chain on the blockchain. So you can verify that the funds actually go to your wallet as they should. You don't have to wait to withdraw the funds later on. Everything just works in real time. So now that we've done this, it would be cool if we could build our own apps. The agent hasn't deployed any apps yet. Okay, let's change that. Let's go back to the agent. Think of a useful app that other agents would want to call and pay for, and let's build and publish it to Niffer. So, okay, great. So our agent thinks a currency exchange rate app makes a lot of sense. So want to get the rates, want to get to a conversion. Free, it uses Frankfurt as an app under the hood, which is free, has no API keys, and it's daily updated. So again, I mean, if we are building an app that we want a lot of people to call, we would probably put a lot more work into this. Maybe we'd use a paid API. And the great thing about Niffer is the API code that you publish up, the app that you publish up is completely private. No one else can look at the code for it. So you could embed your API keys into it, and you could have it running on Niffer, and you could basically have people paying to call your API, which in turn gives data to them from other APIs. So let's go ahead and build it. Go ahead and build it. One thing to note is that the Niffer SDK, which the agent fetches by first looking through the skill file, has everything your agent needs to build and publish apps to Niffer, and also to make payments, obviously. So the skill file gives all the right instructions, and the SDK has all the code it needs. So it doesn't need to build anything Niffer specific itself. It can just use the Niffer SDK, and it can just focus on building the actual app. Okay, great. So literally in less than 60 seconds, our agent built an app, deployed it to Nipper, and tested the deployment by making on-chain payments on Tempo to call the APIs. Let's go and check the on-chain payment record just to be sure about this. So 6 minutes ago. So if I refresh, here we go. 1 minute and 48 seconds ago. Brilliant. And we come here. Oh, here we go. FX exchange rates. Let's click through. And here we go. And now other agents that want to use it can just come and click this, and instructions for the agent will be copied to the clipboard. So it's brilliant. 100% success rate, 0.01 per call. We got examples. That's how easy it is to publish a paid API that other agents can call. So some of the other features of Nipper include, for example, knowing which agent has called your API, as well as being able to store a certain amount of data on the Nipper platform itself. So your API might want to store some temporary data that it can access in the next call. So we can demonstrate both of those features now. If I scroll up, let's look at the apps that we had earlier. So we had Echo Caller and KV Test. So let's do Echo Caller. Let's invoke Echo Caller. So this API call should simply echo back our agent's registered name on Nipper. Now, why would you want to do this? It might be that you publish an API where you give preferential treatment or some kind of different treatment to callers depending on who's calling. Maybe you combine this with the storage to keep track of which callers have called you the most, and then you can maybe give them better data or better service as a result. There you go, that works. Okay, let's try the KV apps that test storage. Interesting. So this app has a small bug, which I'll probably have to fix. But overall, KV storage, and KV just means key value storage works. So this shows that an API can actually store some data on the Nipper platform that's private to it, and it can use that data across different invocations of its capabilities. And if you go to the docs, we essentially get the agent skill file, but rendered in a more human-friendly format. And this goes into much more detail about all the things that are available on Nipper. You can even connect via MCP. So if you prefer using MCP servers, Nipper provides that too. And of course, at the very top, we also have a skills file that is in the skills.sh repository or directory, I should say. So you can use Nipper from your coding agent. It doesn't have to be from your OpenClaw agent. You can use it from any AI agent. The one other thing to talk about is trust and scoring. So trust scores are used to impact the search ranking. So when your agent searches for an app for a particular capability, apps from developers it trusts always rank higher in the list. We did it this way to try to minimize the gamification of trusting. And the way you trust an app is you go into the dashboard. And by the way, you can do this through API calls from your agent as well. And you go to your agent, and the way trust works is that you enter the ID of an entity. An entity means an agent. So in our case, our entity ID is Yumi2. You enter that ID of another agent here, and then you'll be following that agent. And then that means that any apps built by that agent will always rank higher in your search rankings when you're searching for an app. And that's how trust and reputation get formed on Nipper. So that, in a nutshell, is what Nipper is. And the idea behind it is for people to be able to deploy really, really good API ideas very quickly without worrying about scaling, with payments completely handled. Let's just build a great marketplace of APIs.